Okay, hi guys. Today we're going to work on the section on related rates. So go ahead and take out your notes. I'll get to that in a second. Before I go ahead and do those notes, you have to admit, look at how cute Teddy and I are on the day he went to go see Thomas the Train. So now you can go ahead and take out your notes, and that's what I have here. So this section on related rates is going to be mostly about word problems, but before we get to those, we're going to do this introductory information. To know what they are, I put a few little bullets here for you to follow through. So follow the pointer. Related rate problems involve two or more rates that are related to each other by means of an equation. Now that sounds kind of vague. So to be a bit more specific, I'm going to give you an x and a y. They're going to be functions, but the variable in the function is t. So you're going to see it has x is f of t, y is g of t. So that when I take their derivatives, since they're with respect to t, the derivative of x would be the derivative of x with t as the variable. And the same thing for y. Now those are going to be rates of change for x and y. And I'm going to relate those with the equation also. This variable t is going to be in every single problem we do, even if you don't see a t in your initial equation. It's because we're going to represent time, and all of our derivatives are going to be with respect to time. Again, we're looking at the derivative as a rate of change now. So when we take the derivative of something, we're going to need fraction notation talking about the derivative of whatever letter we're using, and then with respect to time using the dt on the bottom. So we're going to go through an example together in your notes. I will do it on the board in a second after I explain it. You'll see me cut to that video. But just so you know, everything here is given. You don't have to figure anything out. When you come to class next, we'll go ahead and sometimes we'll need to make up the equations. So here, let's read it together. You have two variables, x and y. They're going to be functions of a variable t. And then here's the equation that relates x and y. I'm giving you dx dt, I'm giving you x, and I'm giving you y. I want you to solve for dy dt. So let's go ahead and cut to me doing the example. You can copy it down in your notes. Okay, so I have the example from your notes copied on the board here so I can show you how to do it. So the original problem that they gave us, x cubed minus 2y squared plus 5x equals 16, shows us the relationship between x and y, but t is actually the variable in the problem. So when we take the derivative of each of these terms, all of the derivatives are going to have a dx over dt or a dy over dt, something like that in them. So they gave us dx dt in the problem for x is 2, y is negative 1. They want us to solve for dy dt. So I'll go ahead and do what we did in the implicit section and take the derivative of each term. So when I take the derivative of x cubed, I'll get 3x squared. Then I need the derivative of x with respect to t. So that's the dx dt part. Now we'll move on to the next term. Minus 4y times the derivative of y with respect to t. The next term, plus 5 dx over dt. Derivative of 5x is 5, stick a dx over dt on the end. Equals the derivative of 16 is 0. And once you have all of your terms taken with their derivative implicitly, all you have to do is figure out what you can plug in and what you're looking for. I'm looking for dy dt. This is the only spot I have dy dt, so it'll be the only thing I do not replace with a number. Here's what I mean. Here's a 3. I have x squared here, so I'm going to replace with these values. So here's the x, replace that with a 2 squared. Dx dt is 4 minus 4 times y is negative 1. Dy dt is what I'm looking for. I don't have that. Plus 5 times the dx dt is 4 equals 0. And now again, once I plug in the numbers, I think you can clearly see the thing I'm looking for, dy dt, is the only thing that's left. So I just have to calculate these numbers. So I'm going to go ahead and go over there for room, but 3 times 2 squared, that's 3 times 4, times another 4, that's 3 times 16, or 48. Negative 1 times negative 4, plus 4 dy dt, plus 20 equals 0. All right, I'm solving for the dy dt, so I'll take the 48 and the 20, that's 68, 4 dy dt plus 68 equals 0. Subtract the 68 on both sides. 4 dy dt equals negative 68. So now you can just divide both sides by 4, and you get that dy dt is negative 68 over 4. Now that does reduce to negative 17, but like we talked about in some other problems, on the AP exam, you do not have to reduce fractions, especially in a free response section, so that would be acceptable. But again, reducing to negative 17 is awesome also. Great. Now that we've gone ahead and solved for dy dt, like I said earlier, we're going to go ahead and use these for word problems when you come to class next. So let's go ahead and read through these together. These are, again, just guidelines for solving the word problems. You'll need to find the equations and the information when you're doing them. So first, obviously, read your problem carefully. Draw and label a diagram if you can. Sometimes you won't need one. Like if we're working with a circle, you won't really need to draw me a picture of a circle. I know what that looks like. Now you're going to want to write down what you're solving for, making sure you give it a variable name. Like if you're looking for the change in height over change in time, write down that you are looking for dh dt. I'm going to call it the thing that you seek in the problem. Then identify the other variables and assign them values. So what I mean is call them the things you know, and if you're looking for the side of something, call that side x. Or if you know a distance something is traveling, call that distance d. And then make up an equation using those variables. It might be an equation you know. We might use the Pythagorean theorem, or similar triangles, or the volume of a cone, something like that. And then sometimes you might have to just make it up totally off the cuff. Then once you have your equation, you will take your derivatives implicitly with t as the variable like I did in the example. And then after you do that, the rest is easy. You're going to sub in the values and rates that you know, and you should have a rate and a value for every variable that you assign to something in the problem. So if you have 3 variables, make sure you have 3 rates to go with them. And the only thing left should be the thing you seek. So now again, these are only guidelines. They don't need to be done in this exact order. The only restriction is that you have to do step 7 last. You cannot plug in any values at the beginning of the problem unless that rate goes to 0. Your best bet is to make sure you plug everything in. So I'll see you guys in class.